to this final session of our FDP. Today our speaker is Mr. Tejas Morkar. He's an associate software engineer at Veritas. I want you all to give a round of applause. Now I would like to request you to present our speaker.
Because he is alumni of our Mangatos.
I'm very proud to have him here.
So hi everyone, good morning. Finally the setup is done and we can start now. So yeah, this is more about introduction to GANs, and we'll also see what generative AI is. But actually I just wanted to know the audience that how many of you are aware of generative AI and how much do you know it, because the audience that I have had before was of colleges and students. So I have everything from beginner.
So same will do.
Yeah. Is that fine? Okay. Yeah. So it's exploring the potential of generative AI, and the hidden agenda is to promote the idea of GANs and induce the curiosity of doing the research behind GANs and finding the interdisciplinary applications of it. Because I personally like GANs and I would like to promote that. And so it's no more a hidden agenda right now. So first of all, why should you listen to me? Because actually I'm not an expert, but I am a machine learning enthusiast. So it's not a degree, but everyone who's doing machine learning, they call themselves as machine learning enthusiasts. And yeah, but I have worked on a handful of machine learning and deep learning projects. And my keen area of expertise lies in deep learning, because I wasn't more into choosing which machine learning algorithm I want to use, but let deep learning handle it. I know it's a little bit controversial, but that's how I used to do it. And so I have trained a lot of models and always not proud of their results, and deployed a few of them, because mainly when we run it in a Python environment, it just stays there. So I believe that we should deploy them and share and see how those perform in actual life. And also one promotion here of a 100-page machine learning book. So it's a read first and then buy. So it is what I've found very helpful. So you can just go online and check it out. So whatever topic you like, you can just go to it, and it is just 100 or over 135 pages. But if you like some topic, there are some QR codes, and you just go deep into internet for that.
What is the name of that book?
So it's the 100-page machine learning book. It's by Andrew Barker. If you get the PPT, the links are also there. So that is what helped me a lot in finding the topics that I like and exploring them.
So first time I think in the FDP, I am seeing a promotion of a book. So book era has gone, but now today.
Yeah, actually I read the free version of it online, but then I wanted to have a copy, so I bought it. Yeah, so the problem statement, what we'll do is, we'll focus on a problem statement which can be handled by GANs. So it was one of my projects, sketch to color image generation using conditional GANs. So there are types of GANs that we'll look into, but this uses conditional GANs. So what was the problem statement is that there is an input image and there is a ground truth, the image, but the sketch is the input image. And what the model has to do is generate an image which is closest to the ground truth. And the only dataset I could find was the anime one, but I'm not a fan of anime. That's just the dataset I came across. It's on Kaggle, and the link will also be there in the collab. Yeah, but why use GANs for this? So for that we'll need to see what options do we have in generative AI. So there's a Bayesian network that we all must be knowing. So it's like there's a fixed formula. So a probability of A given B we have to find, and there's a formula that we all study. But yeah, the main thing is it's a fixed formula, and it is just hinging around what the probability of something is given something else. Then there's Boltzmann machines. Actually, this is very interesting, and the person who invented generative AI, Ian Goodfellow, he also talks about how Boltzmann machine and restrictive Boltzmann machine actually helped him get into this idea. So I would also suggest if you read about that a bit. And then there are autoencoders, variational autoencoders, and GANs. So we'll look at 3 of those because they are a bit together if we look under the umbrella of generative AI. Yeah, so autoencoders. It's just used for unsupervised learning and dimensionality reduction if you just look at it in a brief context. So what it does is you have an input image and it will just encode it to a very small representation, and that is what we call a bottleneck. So in between it will have a very small representation of it, and at the end you will want the forward decoder to just decode it to what it would have been earlier. So if you just think about it, the main application of it, what they thought was, if let's say there is an image that someone wants to see on their mobile, so what they do is they can compress it, and then the compressed image we will have, and we have a decoder. So this is the basic idea behind it. But why we can't use that in the problem statement we have is it's just a compression type of thing which tries to exactly match what the input image was. So you can take a simplest loss function like the mean square error, and that's what it does, just tries to find what the input might have. Then there are some limitations to this autoencoders, like lack of continuous in latent space. So however it is storing the decoded file into the the matrices data into the bottleneck. Over there the space that it has is very rough and very like there are too many dimensions involved which we can't read through if we try to go into it. And this means that the small change in the latent variable which is in the bottleneck can vary a lot for your output. So that is not what we want. And then there's overfitting. If your model is too complex, the layers that are encoding and decoding are too complex, then for a simple data set, it could just overfit. And then limited in data generation. That's why it's limited in data generation, as we see. That is just about creating what it had earlier. So then there are variational autoencoders. That's what they do, like the limitations of autoencoders they are trying to cover up. Like let's say continuous and structured latent space. So how they bring this in is they just have a regularized training using a divergence, that is scale divergence. And using this they are trying to fit that latent space into one let's say distribution, which generally is a Gaussian distribution. And this has the capability of improved data generation, because if you see, if you have an input, it takes its mean and standard deviation into account, because that is what we take for distributions. Like let's say there's a standard Gaussian distribution, so mean and standard deviation of this data, and then that is a sample latent vector that they are having, which is why if it stays there, it is a kind of continuous representation of what it was. So that will help the decoder find out the outputs the way, like it won't be very rough, like even if you change the latent space over here, the images that are outputted are not varied too much. And also some of them also found that they are very correlated. So there are like too many dimensions, but if you move across one dimension over here, so changing in one dimension can mean that it is just moving the head of a person, or let's say another vector they get, it's just changing the hair of the person. So that is something interesting that they found. And yeah, so what it actually is an encoder and decoder. And if you see over here, it's just a mean and deviation of the input that they are getting, and they are trying to map it over it. So one key distinction is that they treat this space as a probability space, as we saw. So that is how they are getting it so smooth. But one important thing that you'll hear about variational autoencoders is that the reparameterizing trick. So what they do over here is, so we need back propagation to learn something in the backward pass, right? So when you have a definitive or distinctive data, you can't do a back propagation calculus over it because the chain of rule, the rule of chain. So what it does is actually removes the distinctive part aside and uses this epsilon, which is the sample from standard Gaussian distribution, like the mean of 0 and standard deviation of 1. So what it does is it maps over into that something which is regular, and then you can find back propagation for this. And then there is this balancing reconstruction. So it is similar to autoencoders, where this first part is just they are trying to get the loss of the last and the input, but then there is this scale divergence that they are putting in to have that ability to move it probabilistically. And there is this beta that they use. There is obviously a trade-off. If beta is very less, close to 0, then the term K divergence won't mean anything, and it would be like a autoencoder. But if it is too high, then there are things of overfitting and such. And so then we come to generative adversarial networks, GANs. So what we'll understand first is what actually generative means in this, then adversarial and networks we know. So there are two types of models, discriminative models and then generative models. So the main purpose of discriminative models is, let's say you have a space, but for now we'll take it a 2D space. So X versus Y. So here are some circles and here are some triangles. So if you take a simple algorithm which will find a circles versus triangle, maybe it will provide this diversion. So what we find in discriminative models is that you have to find Y given X. So let's say you have a point, you will just have to find the Y of it, and you will understand if it is a triangle or a circle. So it's giving a distinctive output, yes or no, or it may be not just binary, but in this case it's a 2D one. And what generative models are, that it is a joint probability of X and Y. So basically, if you have a joint probability of X and Y, it will find out how the data is and try to generate it over there. So if you find the X and Y point of that, it will provide a new data point which is much likely to be seen as a triangle. But if it's a XY of below ones, it will be much likely to be a circle. And then there is the adversary part over here, which means we are pitting one model against the other. So that's what I like the most about it in the GANs. So there's one model that's generating stuff, and then there's another model that is discriminating between is it a fake thing or a real thing, which we'll see further in an architecture. Yeah, so we'll dive into it, what the architecture is. It's basically you have a generator model as we said and a discriminator model. So you will give an input noise vector to the generative model, and what it tries to do is create a fake image. So let's say we have a training data set, and over here it will be not labeled, right? So let's say you have images of cars in the real image, and there's the generator model which will try to create a fake car. But if it is not trained, it will just give out some noisy matrix. And when it goes into the discriminative model, what that model has to do is find out if it is a fake one or a real one. So the job over there is very simple. You can just have a simple CNN in case of images, which is just doing a binary output if it is fake or real. And then it has to just check up against this real image, and then the loss that it has in the backward step, it goes to the discriminator model for finding if it is really fake or real, and then it also passes down to the generative model that what went wrong and what you could have done right. So what happens here is generative model is trying to give a fake thing, the discriminative model is saying no, it's fake, you have to do better. So it tries to make better, and somehow we think then it has to get so good that the discriminative model will think, okay, so it might be a real one. So in real life, what you can think about is like a counterfeiter and a police. So over there, they'll make fake currencies and police will try to stop them. But over time, the counterfeiters will get very good. So good that they'll have real money, which looks fake money, which looks like real money. but then police will have to do better, and then they'll also have to find new ways. So this is a kind of a never-ending game, but it's like a min-max game. So what the generative model is trying to do is increase the loss of discriminator and minimize its losses. And there comes a point that the discriminator models, this efficiency is at the lowest, a saddle point. It is known as the Nash equilibrium. So that point is difficult to get to, but once we are there, then the discriminative model is just trying to guess. It's like a 50-50% chance that it's real or fake, and that's when you know that it's to a saturation like equilibrium. But sometimes it's very difficult to reach that because of some issues like mode collapse and all, which we'll see. Yeah, so then there are types of GANs as we saw. We are going to try to make a conditional GAN work for our problem statement. But then what is the first GANs? So Ian Goodfellow, who invented it, by the way, he was in a bar sitting with his friends talking about something, and it just clicked to him, and he went home and coded that night, and it worked. So that's why I also believe he was a researcher who knew how to put his thoughts into a code. So that is why he could do it overnight over there. So that's a very good thing to have, to know, like we know the architectures but also to build them. So over here you can see the MNIST data that he had generated. Then there is the phase data, and I think there is CFART in this data set over here. So the quality of these were not so good, but it was something very brilliant. Like Jan LeCun, who is also received ACM Turing Award, had said that it was the most innovative idea in machine learning for past decade. So that was something huge. It was in 2014. So in terms of machine learning, it's like a recent thing. Then came the DC GANs by Alec Redford, and over here what they tried to do is they found out that they named it DC GANs because they were using deep convolutions in there, and that is what Ian was also using, but it was not thoroughly researched that what type of convolutions he had to use. So over here they found out, like if you use more than one strides it will work better. Like they did some testing and research, and they came up with output that was very good. But one interesting part about this is, like if you know the encoded part of a word vector, so let's say we are representing a bag of words on a vector like in a dimension. So what happens over there is, let's say there is a vector representing twin, and then there is a vector representing man and woman. So if you subtract a female vector from twin and add a male vector, it actually gives a vector which is very close to king. So that is what happens in that space, and they found out that it works over here also. So if you have an image of a man and you subtract the vector representation of like with a sunglass, and you subtract without a sunglass and add a vector of woman with sunglass, it actually gives images those are close to women wearing sunglasses. So that was something interesting that they discovered. Then there is progressive GANs. So this was nothing but trying to increase the resolution of the images, because at that time the point was that they are trying to create images, generate images, but those were not usable anyway because of the scale and the pixels that they were providing. But this was the first time when they actually found out that if you first train it in a very small size vector and then initially increase till 1024 by 1024, it actually provided very good results on scalable data set. So these are some types of GANs. Those were actually turning point in the research and from where it started. Then there is this SR GAN, basically super resolution. So they have a real image of a super resolution. They just use some blurring mechanism like bicubic average of the image pixels, and then they give it to the models to increase the resolution. And then they had the result with SR GAN, which was very similar to ResNet of like super resolution ResNet, but actually it seemed very original, but it's something that is generated. So there were some points which are blurred, but it has to be seen very neatly. So one issue in GANs is that you cannot define how good the model is, because it is all subjective to what it creates. It does not have actual metrics on which you can count. And then this is the conditional GAN that we'll be using. It is basically used for image to image generation. Let's say you give one type of image to it, and it is going to create another type of image. Like let's say if you give satellite images, it can create a map out of it, or vice versa. Or if you give a sketch, it can give you a colored photo of it. And it is used also in image sections where the data is missing. It can basically generate data over there also. Yeah, so some basics. This was just what artificial intelligence is, and like I don't think we need to go over it. But if there's anything, you can just stop. So deep learning, hidden layers, actual neuron, activation functions, gradient descent, batch normalization, dropouts. Then common DL networks, some common. This is a recurrent network. Those are some recommendations.
Some points to be said.
Yeah, so basically, as you can see, some convolutional neural network, I think yesterday was the session. So it's basically for images, where it creates convolutions, and first from the convolution it tries to extract the features. So that is mainly used for the images, or let's say audio, when they are represented as images. But recurrent neural network is something that is used for text generally, or a sequential data. So there it is based on the time the data it has. So it can basically, the main thing of RNN is they should be able to understand what came before the word they have. So it is mostly used in a sequence, and like they have the ability to remember what the data was and try to connect with it. So there are various types. This is just the basic RNN, but there are various short-term memory and LRUs that are with it. So the language models that are there, like the ChatGPT and everything, what they basically have is a recurrent neural network, but in a very, like this is very basic, but they have a complex RNN. And yeah, so I had a collab book with me that I had created. So right now I'll just try to go over it, and then you can, like I'll try to explain everything, but if there's anything you can just stop. So this is the collab. I had already ran it yesterday, and basically I'm using TensorFlow because that was what I used before, or it can also be done on PyTorch if required. And basic starting the Kaggle dataset that I mentioned. So there is a way that we can take entire data on our Google Drive, so it becomes easy for collab to work through it. So this is just that, unzipping the folder. Yeah, so now there are some variables that need to be set, and in terms of GANs, these are kind of important. Like epochs I had set to 10 because GANs, one limitation is it takes a lot of compilation. So the actual project that I did on my laptop that time, and it took around 23 hours for 150 epochs. And I could have used Colab, but I just bought a new laptop, so I was just trying over there. And buffer size is 502 over here. You can increase the buffer size to speed it up, but then it will require more RAM. And similar with the batch size. So now the main thing about the images, how the data set is. So this is something that I just written on the Medium article. So the data set is one image, that will be 512 plus 512 width, and the height will be 512. So in the pre-processing, what I had to do was just take a half of 512 by 512 and 512 by 512, and by that I'll get a sketch and ground truth. So what our input is, like this should be the real one, and we are going to provide that as image input, the vector that we saw in the generative model input. So in image to image, like conditional GANs, we provide some matrix of an image. So that is what's done over here. Just divide the width by 2 and just get that, load that image in the memory. And pre-processing steps that have been done is to first resize it for proper input. As we know, the input layers require proper input height, width, and the 3 channels if it's a color image. And then random crop. So we require data augmentation. So some of the very common things like randomly cropping the images and then resizing them to 512 by 512, then normalizing the image, and basically this random jitter function will do all of them, and randomly it will also flip. So we have an image, we can just flip it, so that can be also used. So we have to find ways that we can work on our data, how much we have, but increase it kind of by cropping, by flipping and everything. So finally we get such kinds of images. And TensorFlow then has a very proper way of handling how the data set is inputted. So this also, you can just go through TensorFlow documentation if required, and it has been properly documented over there. So what it does is, in the training folder, it will just find all the PNGs and input it, and similarly for the test images. And now comes the important part, is like building the generator model. So generator model over here is a unit architecture. So basically it will have convolutions with, which will downsample and upsample. And also the main thing about this unit architecture is it has many skip connections. So those skip connections actually are to preserve the attributes or the features that it is learning in the initial ones, so that they don't just fade away. And due to this, while making like coding about this layers is very important, because those skip connections have to match what size you are providing. So let's say one layer has an output of 512 by 512, so that skip connection should go to a layer which can input 512 by 512. So in such way, we have to take care. Output channels are 3 for this colored image. We can directly go to how the model looks. So this is the generator model summary. Over here you will see there are layers on every step, so like a U shape, and all of them will be having interconnected skip connections. And discriminator model on the other hand is very simple. It just have to be a model that can be a binary model, real or fake. So this is just that model. And yeah, so for this all you have to take care of is you need the input images similarly as they were as they are outputted by the generator model, because that's the input this discriminator model will have. And then there is just downsampling and padding and all the convolutions. So like we saw in the papers when they research and provide some data like strides of 2, and then there was this lambda for this loss function that they suggested should be 100. So these are some things that are just there because they have been gone through. And the loss function for this generated output, it's nothing but lambda loss of the actual image. So generator is what it's trying to do is maximize the discriminator's loss, and discriminator has to minimize itself. But what we are trying to do is generator will want a real image. So let's say discriminator gives 1 for real and 0 for fake. So generator always has to take it to the high ceiling like 1, and the discriminator wants it to 0 size with all the zeros, and that is what the discriminator loss is trying to do. Then there are the optimizers that have been used. So Adam optimizer is one that is always used in these models. So those are some hyperparameters that were already present for us. And then while you're doing this in a collab, it's important to have checkpoints. So whenever it just disconnects, if it is a free version, you can just go back to those checkpoints and you can go over to it. I know like it's hard to follow through on a machine, on a screen, so you can have link for this and you can also go through it. And I've just then logged some losses, and then the train step. So basically in training what we are doing is, for discriminator model we are assigning whatever function we had for the loss and for the generator model, and then first we'll give it to the generator model, then it will go along and it will create some image from the input noise, and then afterwards this output will be given to the discriminator model, and then it's going to try to give the output. That's it. So once you fit it, so basically in starting, let's say that it has predicted this and it knows what the loss it has, and through backpropagation it understands how to correct, and through epochs it tries to get better. And once you restore that, this is the example of after 10 epochs how the data, how the model is performing. So just after 10 epochs it is kind of a good result for this, and when I tried it for 150 epochs, so on the first epoch it is just giving some random output. So from this image you can understand what the generator model is trying to work through. So it's not just about coloring some images, it's about actually generating them from scratch. Yeah, so this is the output after 150 epochs, and as we'll see about mode collapse and how if you even try to go to 300 epochs or something, it may get stagnant over here. So after a point there is no use of actually going through the epochs, because it comes to that like it is not able to escape that local optimum, and it gets stuck somewhere. So there are ways to avoid it that we'll see further. And then I had my friends draw some sketches and then provide those input, and those were some outputs that are there.
How we decide the color combinations for an image?
Yeah, basically it's not trying to give the color combinations, but what it's trying to do is just provide some output given the input noise. So what happens is, through the gradient steps that it receives what it's missing, it tries to provide actual pixel values to that. So that is the thing how it tries to learn what it has to output. So always it won't be like in ground truth, let's say the shirt is green, so it won't always be green in the output image. It will be some other color, but it will match to the entire distribution that okay, some shirt should be colored, some skin should be skin colored. So it just tries to generate those things.
Randomly?
Yeah.
The color pixels
Right.
So that's why we introduced the noise in input image.
Yeah, so actually the first noise that was there in the GAN architecture we saw, it's just something that we provide, it can be anything. But in conditional GANs, the noise that we are providing is actually the sketch image. Because it is, conditional GAN is image to image, so sketch to color, or let's say factored images to actual buildings. So over here the noise input that we are giving is actually the sketch. So that is the noise for generator model. And on that then it is trying to generate some pixels that will hopefully be the near to the ground truth.
Okay, that means it is useful in movie character. You can say that suppose some hero want to put some character, so instead of trying so many dresses put on him, so we can try by his hand.
Yeah, right. Actually, yeah. So that's one thing. And right now, if you see what is being used, so videos is something that is difficult to process, and it's been worked on. But right now, what we see, let's say in Adobe or any Photoshop tools, you actually now have the ability to, let's say there is a mountain, and you want it to be a snowy mountain. So actually, there is a way you just spray some white, and it will actually create a mountain which like it looks so real. So there are some demos and applications we'll see. By that we can understand.
What is the input image, real image and ground truth?
Okay.
What we give to what actually? That I wanted to ask.
Yeah. So basically, input, ground truth and predicted. So the data set that we saw, that had the ground truth. That this
Based
is how.
on that it is getting trained.
Yeah. So this is how the image should look like. But what we are giving as an input is this sketch image.
Input that will be at the time of testing or
Training.
at the time of
While testing also we'll provide some
yes.
input image.
Ah.
And while training we provide this. And what happens is that the generator model is receiving this sketch image and it is trying to generate something like this, but at start, as you saw, there was noise vector.
Right.
So that will be given to the discriminator model.
That means in ground truth we introduce some noise in input image.
ground
No.
truth only
So ground truth is only for the discriminator model to receive that how the real images look like. Generator model won't know what the ground truth is. All generator model knows is that it has this and it has to output something, but it is not sure what it has to output. So how will it learn that is when the discriminator model provides some inputs that okay, it's not like this, it's fake. And how it learns is through that back propagation. So whatever the loss is there, so let's say it provided some image which is not actually colorful, and what the discriminator model wanted was something like this. So some loss function between them, like the mean square error, plus some other parameters that they have chosen, and those will propagate back to the generative model, and then it will understand, okay, let's try this.
what is real image?
So this is ground truth is the real image that we want, but that is never given to the generative model. Yeah, so in the diagram that you saw real image, that is the ground.
In this case, these two images are having some error, na?
Yeah, right. Yes, this is after 150 epochs what it had. So this is just a simple representation of it. But if it now if you see the demos what actually NVIDIA has created, so we'll see that we can't even differentiate through our eyes what it is.
Now, whatever you wanted to color later on, the as it is sketch you have given, same as that of ground truth.
Right.
Is it the case like that at the time of ground truth you will be giving somewhat similar or different some images, and out of it some features, color or some texture it will be taking, and that it will get applied to the input image which has been given. An input image which has the boundaries different than the ground truth.
Yeah, so it will be totally different. Like at no point
But
will
here
there
you
be.
have given the same boundaries or boundaries.
Yeah, to see what the output is.
Yes.
Like this is not present to the generator model at all. And let's say a discriminator model receives this. Discriminator model is not sure that this is the output that it wants. Because we are training both the models.
Yes.
First, the discriminator model is learning how to differentiate fake and real. And also at that time, generative model is learning. So it won't have the ground truth also. It will just try to say it's real when there is a noise. But then the ground truth we have at the end that no, it wasn't real. So then it will learn accordingly.
So in training data set it is not there. This original image.
Yeah, original image is there, but it is not connected to the input image. So let's consider this as two different things. There is a discriminator model. It is just receiving all the images from real data set. So we don't need to label them explicitly. We know that those will be real. And whatever it is receiving from the generator model, those will be fake, is what we know. So how we will code it is whatever is coming from the generator model, will be fake, and whatever is coming from the real data set, that will be real. But now discriminator model doesn't know that, so it's trying to learn. So first it will say like something wrong. Let's say it identifies as fake, the real. Then, but we know like we have kind of labeled it that what real is. Yeah. So this is one case where discriminator is learning, and then the other part is when generator model provides its output. All it wants is the discriminator model should think it is true, but when it does not, then it learns what it should.
So now we have trained on all human images. Suppose if you give some animals, what happens?
Right. So in that case, it won't work properly. It will try to do something, but it won't be as proper as this. But then further, we have something like transfer learning. So the generator model that we have done here, we can take those things, and in transfer learning, there is a concept of you can pass whatever it has learned, the knowledge of it, to the newer data. So even if the data is less or compute is less, it can easily do it.
We can train with the new data sets, and accordingly then we can give the
Right.
input.
So yeah.
Where it is getting combined, like here from the generator we got the input image features, right? And from discriminator we got ground truth features, and now we want to generate the fake image. So ground truth features will be given to the generator, and then
Architecture.
can you show that architecture? Yes.
Discriminator and generative model two are different things.
Yes.
I think discriminator
real
is
image.
trains the model based on the real image.
That is yes, that is there.
The
But
sketch,
we
rough
want to
sketch
combine. We want to combine.
No.
And
So
generative model introduce some noise, fake image. And
those models-
Real image is there.
Yeah.
Then discriminator.
Right.
Generative model will be giving fake image that is only sketches.
No.
no, any
Sketch. Let's say now this is a conditional GAN. So instead of vector, it will be some image, the sketch image.
Okay.
So the sketch image goes to the generator model. Now don't think about the real and discriminator model for
Yes.
now.
Okay.
So the sketch image is given to generator model, and it will output something based on this. Let's say it multiplies every pixel value by 1, and it outputs. So it will output the sketch itself, and then it will go to discriminator model. That's it for now. But what happens in discriminator model is this place where it gets real image from, and it is this place where it gets fake image from. But it is not sure of that. We are sure of that. So in a way, we have labeled anything that comes from here should be labeled as fake, and anything comes from there, the real ground truth images, those should be labeled as real.
But after applying that color, it will be checking for real or fake.
After
After
this,
discriminator model, what it is doing is, it is
discriminator-
calculating the loss between fake
It's
and
at a time
real,
we
and
give
then
the
it
two
is
input.
back propagating that.
No, just-
that is fine. Oh, loss calculate कर रहा है.
in the fake and the truth, both.
So-
Real and the fake.
okay, just instead of finding for the generator model, let's just think about discriminator, and let's say it's not attached right now. We have labeled images. let's
Coloring
say.
the sketches के लिए ये real and fake will work. It is going to discriminate that.
Real change is what?
So please explain.
Yeah.
Understood that. I
Yeah, so
understood.
basically there is no
But what
generator
about-
model, and
Coloring the sketches.
you have labeled this as fake image and this as real image. Now let's say cats are fake and dogs are real.
Real.
So cat images versus dog images, you are providing to a convolutional neural network. What it has to do is based on that learn what is a cat and what is a dog. Right? So let's say we are providing a cat image over here to generator model. It has to do something to that. What is an image? Like just a matrix with values. So it has to do something to that matrix of cat that it generates a dog from that. Right?
Okay, look like
So-
a dog.
Yeah. So let's say now this is already trained in finding what is a cat and what is a dog. Now it is trying to make a cat into a dog. But right now when it gives it to a discriminator model, it says no, that's not true. So then it learns, okay, so I have to do something else. And it again tries it. And there will be a point when it will go through. But from that, the discriminator model will understand, okay, I did something wrong because this was by the label, it was a cat, but I identified as a dog. So then it will learn on itself. So those are two different things. And we won't ever combine them. Let's say now we want to generate something.
But in case of color sketch, you are sketching the color.
Color,
Coloring the
yeah.
sketches, right?
Yeah.
So in that case, what will the output?
Yeah, so in output will be a colored image.
But yes.
Right.
And it is going to discriminate like it is through same as that of real image or something like that?
Yeah, so let's say it is providing a colored image. Now you're asking about the discriminator model.
Who will be giving the colored image?
This generator model, when it tries to learn.
But you have given the real image will be coming from there. No, ground truth will be coming from there. No, which is colored, right?
Okay, colored image as in you're saying the actual real image.
Sketching that.
Only
You have given the
sketches
sketching.
where you want to
Yes,
say
and that coloring you want to do.
Yeah.
Coloring the sketches,
Right.
right? So in that case, what will be the input from the real image and what will be the input from the generative
Yeah,
model,
so-
and then what is real and what is fake there?
So over here, those two don't work together in that way.
Ah,
So over here, if you're saying if there is a sketch and you want to color,
yes.
then only this model comes in. That you will give a sketch to this and it will give a color. That's it.
Color, how you are going to get there?
Right. So it just provides a color, but let's say it's not correct. It's all black and white. So now that when it goes to a discriminator model afterwards, then that model will actually tell the generator
From
model.
discriminator it will learn like what are the actual color pixel that image should have.
But here we have given only sketches, no?
ठीक है ना, but
So
from
it's
discriminator it has
So
learned.
it's
ना,
not about-
from
But
the
what about
image.
coloring to it here at generator model? From
It
where do
gives
we get the colors?
predictions.
From discriminator.
Discriminator.
So actually, it's not about colors. In this specific thing, we are trying to color, but it's not actually coloring an image. It's actually just inputting some noise and outputting, let's say, some noise.
Yes, that is
diagram will show that some pages and color of pulses are coming.
Rough sketch है.
So,
No, here
Discriminator
for
model through real
discriminator,
image चा color
ground truth
discriminator
image
model
is
through
real
learn केला.
image ना.
ते नाही कंबाईन करत म्हटलेत ना ते.
Combine नाही करत आहे.
Combine नाही करत. From discriminator it has
पण
learned.
मग जनरेटर मॉडेल कडनं कलर स्केच कसं गेलं तिकडे डिस्क्रिमिनेट करायला?
Color sketch जाणारच नाही तिकडे. Generator from
Okay,
generator
okay,
model
okay.
it learns like for this sketch what can be the color pixel.
So how
From
we
where it
got that
learns
color information there?
from
Okay,
discriminator.
discriminator identify.
So let's be on zero epoch, like no one knows anything, and we provide a sketch, okay? And
So that pulses, na, you had given the example.
Yeah.
Some pulses, sketch is there and color pulses.
so on zero epoch, what happens is you're providing a sketch to the generator model, and what it will input is this, some noise, right?
जनरेटर मॉडेल
Yes.
ते है हाँ.
Because it has some layers inside it, convolution layers, which are doing some mathematical calculations on this matrix. So it provides some noise, right? So that is the first step over here. Yeah. So this is some noise. That's all it is doing. And now let's say the discriminator model is already trained. What is real and what is not real. So when it goes over here, discriminator model says that it is fake. So over there are some calculations like finding the loss of what actually it is expecting, but what it is getting. And that loss is not in terms of, I think this is the confusion, that it is not in terms of it should look like this, but it is this. We are not actually trying to do the
Something
sketch
else.
wise. It is just a distribution that how colored images look in general. So that is the loss that it is getting, and then because of that, generator model gets to know that it has to tweak its weights in a way that the after calculation some color is provided.
So that loss, whatever gets calculated,
Yeah.
it will be a difference between actual color pixels and rough sketch color pixels.
Right.
From that it decides.
That is done for the discriminator model, and that is passed on to the
Right.
generator. So that's the basic working of how that GAN works. And once that is done, there's a process of deploying some models. So right now we saw there were two models, the discriminator model and the generator model. So in our case, what we need is we give an input of sketch and we are receiving an output of colored image. So here it only requires the generator model, not the discriminator model, because discriminator model is only learning how to discriminate. So what we will deploy in our web app or let's say any application is just the generator model, and we know what we have trained the model on because 512 by 512 images. So all we have to take care is whatever we are receiving, we just resize it to 512 by 512 and that is what so that is what it is here. That this was never in the dataset. I had asked my friends to draw some sketches. So when the generator model gets this sketch, it tries to color it, and right now you can see all over in the background also it is some noise, but in data, the training data, it was not there because it is outside of training data, so it needs to be better. So this was just after 150 blocks.
What is the limitation of epochs in GPU here? Epochs. There is some limitation?
No, not for epochs. That is just for our computational thing. Like for me, it took 23 hours for 150 epochs. So it's on us. Like let's say we have more compute, then those 150 epochs can be done in 2 hours. So how much time do we want to wait? Is that epoch? And for the batch size that we said 28. So it is a very small batch size. So if we increase the batch size, the RAM should be greater. Let's say the GPU RAM or the RAM that we have. So there the batch size is important. But once the generator model is done, we just saved it, and from TensorFlow, saving is as simple as generator.save, and it will have a model with .h5 extension. So that is a model that you can use actually anywhere, let's say by using TensorFlow.js, or there are some other libraries. So when I was trying to deploy this project on a web app, I was trying to do it with TensorFlow.js because as I was using TensorFlow, so TensorFlow.js naturally. But there were some issues at that point that, as I said, it was a unit architecture, it had various skip connections, and some functions were not available in TensorFlow.js libraries, which is why it was breaking. The model was not getting actually initiated over there. So I came across Streamlit. So Streamlit is something that you can really focus on if you don't want to get into web apps and anything, you just want to focus on machine learning. Because over there, it's a Python library to deploy Python projects as web apps. So it can be any simple Python project, let's say just addition, subtraction, or let's say in our case a machine learning model which is in Python. So let's say we have a Python framework all over, and then we try to learn Django or Flask, which is what I did, because I knew if I need a web app with backend of Python, I need to learn Django or Flask. But it was very time consuming, and then I came across Streamlit. What I had to do was, I already had the code in Python. I only had to add just 12 lines of Streamlit code. And what it did was,
where it uses any cloud service?
yeah, so basically it's a library that we'll get on our system. Then there's just a simple pip install Streamlit, will just install it, and you just have to create an app, Streamlit run, and whatever your Python file is, it will create all the assets and you can directly deploy it. And this basically the 12 lines
Is
of
it like GitHub?
no, not GitHub. Basically, you'll get an output where all the HTML, CSS, everything is done. All you'll have to do is put it on GitHub or any server that it can run on. So deploying it as Python file, but where people can actually access it through web apps. So that is what it did. Yeah. So it's just importing Streamlit, then just some caching around it, and whatever inputs you want, there are just placeholders, and that's all you have to do. So the comments over here is basically what Python code I had already, like let's say loading the generator model and all of that stuff. All I had to do was 12 to 13 lines of Streamlit code, including the import statement, and it was finally ready to be deployed. So I used Heroku and deployed over there. So this is something that you can use, because what I think is like because of some YouTube person named Andre, he said no model should live and die in a Python environment. So whenever you're making something, try to deploy it, and that is how you understand what application needs, because like I tried with JS, but that is not what was supported. So this way you get to know how it can be actually used in some applications and it can be deployed.
So it simply converts our Python code as a web app.
Right. And once you run that Streamlit run app, so whatever changes you make, you just save them and it automatically generates a new. And it also has option of screen recording in itself. I think there is no. So it has everything. So its purpose was to make such web apps. Those can be recorded and showcased around. Those people, for those who don't want to get into web app coding, but actually want their mind. Actually, it got this that they can use her face and she gets the royalty.
GAN will change the world next coming years.
So, but it also loses the job now.
Yes, yes.
There are only
Photographer job is right now in trouble.
Yeah.
New jobs.
But it should be learned, no? Techniques.
Okay, so this FDP also is for us to upskill ourselves.
Yeah.
basically like the book I mentioned, Life 3.0. So it starts with a 20 to 21 pages small chapter, which is imaginative, but it puts this point very well. Like what a individual organization can do with such a model. So you see basically what they at the end do is take over all the media houses, news and everything. So whoever has control over news has control over everything. So that's what they do.
लोग इतना बड़ा शादी क्यों करते हैं उसके लिए करते हैं
Alright. How much time we have for this now?
11:30.
We have
No.
5 minutes.
5 to 10.
Yeah, this is the last one. So yeah, the limitations that we were saying. So the mode collapse that I talked earlier, that is basically, let's say now the discriminator model is not so good, and generative model has found one kind of image that always goes through it as a real one. So now it has found a loophole that discriminator model is not good and it can just create one kind of image. So let's say there is MNIST dataset which has 0 to 9 digits. So for an example, let's say it has learned to create ones and twos, nothing else. So that is where it has stuck now and it can't traverse through the entire dataset. So that is a mode collapse thing. And for that then they have different GANs, like WGAN was generated, where they use a different kind of loss in order to make the generative model go further in the space. And one always problematic thing for GANs is no proper metrics to measure how good it is doing. So finally you can find out from looking at the image how sharp it is, how good it is. Like there are some parameters for the image or video or anything, but actually the parametrics for model, how it is doing, are not there. So that is also one place where it is being searched on. The transfer learning we talked about. So basically same thing, that if the cat we saw, basically if you train a model for this sketch to cat image and you try to draw shoes, it will provide a furry type of thing like a cat. So here what you can do is just use this data set instead and train a model, but that will be again compute heavy. And let's say shoes is something that you don't have photos of in abundance. So what you can do is, you have the model already which can do it for cat, then you just freeze some layers of the model. So in transfer learning what usually is done is some previous layers are freezed, so the knowledge is not lost. And the last layers are unblocked and they are trained on small set of shoes image or for very small time. And then it can actually pick up because it already knows how to see a sketch image and how to convert it. So it becomes very easy for it to then do this. And that's how transfer learning is useful.
Any kind from original sketch, any kind of sketch we can do by freezing some part.
Yeah, and training it on a few images of what you actually want. So the resources for this, so obviously blogs, articles, research papers, but I didn't go there because I wasn't searching about GANs. I came across this NIPS tutorial from Ian Goodfellow. He's the one who actually invented GANs in 2014. And in this NIPS tutorial, he's actually letting us know about what GANs are, how we came across it, what can be done with it, and what actually other researchers are doing with it. And that is what increased my curiosity, and that is how then I went to blogs, articles, or research papers that I was going through, which I would haven't ever gone through. And then there's also Google Developers Library where they have machine learning related articles. So there also you can find resources for GANs specifically. And recently when I was just getting out of college, there's this new course, Generative Adversarial Input Specialization by Coursera. So that is one specialization that is available. So that will take you through everything of how to create it and all of that stuff. And others are where you can actually find out how it is used and what you want to use it for and coming across ideas. That's it. If you have any questions.
The resource material.
Yeah, I have actually put it on the side also, the slide.
You mean to say presentation? So presentations like things you can share the slides.
Yeah, I
I
can.
want to provide to all participants.
That link of the given example.
I have also put it on the
You can-
side also. Just for this presentation is already there,
Okay.
so you can
You
just.
can directly.
I'll just
take
share
it.
the.
Okay. Yeah.
And then it will have all the links of GitHub where I have put my
Even
project.
his blog, I was just browsing through all data.
So if there's anything,
Note kar na.
yeah, this is one.
Not there.
This. Yeah, that's it.
Very nicely written. Very nice. His website has all details.
Yeah, if there's anything you can ask now, or you can also get in
Presentation was
touch.
very interesting.
We can use
I had gone to VIT once for the presentation, so in that age group you need to get interaction.
Thank you very much.
Thank you so much.
Yeah.
Thank you, actually thank you that I got to come here and show.
This is on the corner of it. Can we move to also यहाँ पे? Better. Little closer. Is it okay for you?
Yes, ma'am.
Good afternoon, everyone. My name is Shivani Pandey, and it is my pleasure to welcome you all for this valedictory session of ATAL FDP on computer vision for multidisciplinary research. Our esteemed institute, Pimpri-Chinchwad College of Engineering, got a chance to host this 1 week long FDP faculty development program sponsored by AICTE Training and Learning Academy. Our guest speakers were eminent experts from IITs, other reputed institutes, and industry. They took really interesting and informative sessions in the benefit of our attendees, who are professors and scholars of various institutes from across the country. The FDP enabled the participants to explore practical applications of computer vision techniques and receive guidance in developing research-oriented projects in multidisciplinary arenas. It also provided hands-on exposure to work on real-world datasets, implement cutting-edge algorithms, and gain insights into the latest trends of computer vision research. Today we have with us Dr. Aniruddha Joshi from Atre Innovations as our chief guest for this valedictory session. Ma'am, I would like Dr. K. Rajeshwari ma'am, coordinator of this FDP, to kindly felicitate our chief guest.
Thank you very much. 1 minute, sir. Take it from here. I don't get the photos back from them. It should be from you.
Thank you so much. Thank you.
Dr. Aniruddha Joshi is the founder and CEO of ATAL Innovations, with the vision of providing the most personal, predictive and non-invasive health monitor based on data science-driven Ayurveda. He is a computer engineer from Mumbai University and has a PhD in computer science from IIT Bombay, with a specialization in data analysis and machine learning. Sir received the National Startup Award 2021 in the Ayush category. A special mention in Mann Ki Baat by Honorable PM Modi ji was done for him. His excellence in IT awards by Ministry of Ayush DSIR recognition for the in-house R&D of this indigenous value. Sir has 3 patents and 50 plus patents in international journals and conferences, and was a CSIR research fellow for 5 years. Sir, I would like to invite you for the address.
Good afternoon all. Thank you ma'am for inviting me to this particular session. Well, I got introduced to the field of computer vision back in 2005 when I joined IIT Bombay, and the lab which I was part of for all my PhD was called Vision. So it was about imaging and computer vision. Even though my work was more into data analysis, it also involved some part of graphics, some part of computer vision and so on. Today I am going to talk about a bit of what we have done in terms of technologies for Ayurveda, in Ayurveda and so on. So a particular multidisciplinary research-based startup, and some component of computer vision we have used, but now we wish to enter into it. So I'm going to present more about that also. So as I heard in the introduction, most of the sections of computer vision we have already studied now in last 7 days. So let's see which parts of that computer vision can actually be incorporated in our ancient science, which is Ayurveda, so that it benefits to the mankind basically. Just search for computer vision in healthcare industry on Google, and this was the first image which I received. So I just copy pasted as my first slide. So it has so many components with respect to computer vision, specifically in healthcare. I'm sure in last 7 days you must have received all other sectors, and not just healthcare, but security, this and that, and so on. Right? So many components: reducing patient mix-up issues, early disease recognition, better imaging analysis, report automation, and so on. So there are so many components in which vision can be used. The main point is today the world is suffering through the lifestyle disorders, the non-communicable disorders. More than 70% of people are suffering through diabetes, BP, cancer, anxiety, and so many diseases. These are all lifestyle induced. And our own science, which is Ayurveda, has a solution for it. So why can't we create technologies, why can't we create medical devices in and around Ayurveda so that they can be integrated with today's allopathy-based devices. An integrative solution is possible for the betterment of people. 1 in 10 people right now, especially in the West, is doing yoga and in some format, not just yoga in the very traditional way, but in some format. And very natural transition of all those people is going to be Ayurveda. But Western world, even today, especially in India, is not going to accept Ayurveda as one of the interdisciplinary research field unless we provide them data-based or evidence-based approaches. Unless we give them that this is what happened, this is what is the current situation, and this may happen in terms of reports, numbers, statistics, papers, patents, and so on. Unless we do that, people are not going to accept Ayurveda as is. So most favorable time for technologies for Ayurveda is now, because 70% of people need these kind of solutions. Okay. This is a video of Tesla. Okay, when Tesla launched its robo about I think 2 weeks or 3 weeks ago, this is what the robo did. I mean, that robo actually did multiple things for 10 minutes, and at the end, it did some kind of stretching, some kind of yoga, and ultimately it did Namaste. This was its official launch of Tesla robo. You can imagine the influence of us, influence of India, influence of Bharat on the Western world, especially in terms of yoga or the holistic solutions that we may provide, we can provide, right? So this is the need. As I said, lifestyle diseases are skyrocketing. Wellness is the new, is going to be huge than health. So today's health and wellness combined industry throughout the world is 4 trillion, and Ayurveda is in India is just 24 billion. So you can imagine how much scope we really have. If we can create solutions around Ayurveda, around our own science, we can actually make money in India, truly Atmanirbhar, truly make in India, whatever we hear every day from our Honorable Prime Minister Modi ji. This is absolutely possible. So there are so many invasive health checkups. I mean, I see most of us are of age group 40s. So I'm sure yearly we do different types of checkups. Can there be betterments in the checkups? Can we have even more better outputs from those checkups? Because what is happening is that even though the reports are coming normal in those checkups, still people are suffering through blood pressure. Still they are having heart attack. So there is some component which is missing in today's report cards. There is a most important term which is called personalization. The personal touch is missing in today's healthcare. So that's why the interdisciplinary of Ayurveda, allopathy, modern science, data analysis, computer vision, everything. So if we can combine together, we can provide better solutions. Just wanted to highlight before I start the PPT that it's a huge problem. It's a really huge problem, and if we all start working towards this, we can actually solve this. Another slide which I got from Google: reinventing Ayurveda for 21st century. So this is from IIT Jodhpur by Dr. Bala Pesala and Dr. Mitali Mukherjee, and they are working more towards combining Ayurveda with genetic algorithm and so on. So they are working towards that. But you can see that computer vision, multi-omics, digital sensing, so different types of sensors, and of course the AI. There is a need that all fields come together in some format to finally provide the most importantly the preventive science, preventive medicine. That's the time of the need. So what is the future? So it is said that by 2030, we will be surrounded by at least 10 to 15 sensors. Either we will be wearing or somewhere in this room the sensors will be there, and they will be continuously recording different types of signals continuously monitoring us and making predictions about our health and wellness. So there is going to be Google Glass. I think again last week Meta launched the I think some goggle, I forgot the name, but it's a very futuristic goggle. Smartwatches almost everyone is now wearing. There are going to be bracelets, smart rings. So Boat has come up with a smart ring now. Smart bands. So there are going to be sensors in the belts, in the shoes, everywhere. So many sensors recording data on continuous basis, whether they are of the time series format, images format, videos format. There will be different formats in which the data is going to be continuously recorded. So where we can again contribute as Bharat, where we can contribute. Because most of the work is happening in the Western world, most of the work is happening in Singapore, China, and the Western world. So where we can, again, so many smartness. So we are talking about AI, we are talking about smartness, we are talking about advancements, and so on. So very near future. Early morning when we get up, we go to go for brushing our teeth. The mirror starts talking to us about how this day is going to be and what could be the help numbers and how you should spend this particular day and so on, right? So very near future. Corporate is becoming smarter, corporate wellness, we know. So right now I see most of the audience is teachers, but when we go to different corporates, there are so many corporate wellness programs are going on, performance improvement programs are going on, and so on. And again, smart dashboards. We saw during COVID, there were so many dashboards which were getting updated every. So where we can again contribute. So this is what we are doing. Just wanted to share one interdisciplinary kind of segment where time series analysis, data analysis, graphics, vision can actually be combined to provide various solutions. Okay? So the process is called Ashtavida Pariksha. Okay? You can imagine this as 8 X-rays of that time, but absolutely non-invasive. Nothing is going inside your body. Very detailed information about your inner health, inner health. If we somehow create this in today's medical device language or information, they will be of class 1 category, which is very important. So if we study the medical devices hierarchy, class 1, 2, 3, 4, 3, I mean there are different classes and the severity increases, but class 1 is the most which can go to all pathology labs. They can come to your homes. You can do this as more like a lab test, home test, and so on, and can benefit the people. Right? So again, interdisciplinary. When we say if we can combine the best of Ayurveda, best of modern medicine, and best of self-care. Post-COVID days, most of the companies, most of the medical domain, most of the med tech solutions are moving towards self-care. Something you do on your mobile, something which you do at your homes, something which you do on your desk, at your offices, or at your institutes, and so on. And again, just to re-emphasis on the work which we are doing, basically lots of problems, lots of disorders, but the root causes of all those issues, if the work-life balance is not achieved, the problems are very simple in a way. I mean, the problems are not simple, but they are not bacteria, they are not viruses and all. But poor diet, stress, nutrition, anger, hormonal imbalance. So these are the real issues, these are the real problems which get reflected. If they are not solved, they get reflected into the real issues, which is cancer, anxiety, thyroid. And as I said, this number is very high. So the solution is the need. All right. Today I am going to introduce you all in next 10 slides to the field of Ayurveda, so that whatever we learned in last 7 days, you can imagine if something can be worked towards Ayurveda field or not. So the field of Ayurveda is in one line can be talked about the balance and imbalance from the personalization point of view. So there is genetic balance, physical balance, mental balance, psychological, physiological balance, and there are imbalances. And those imbalances are happening because of various issues, and that imbalance is something which gets resulted into a disorder. Again, personalization is physical as well as mental, and there are so many factors in which there are where a personality gets defined. So there are people of look and feel was wise, of this category, that category, and so on. And we know this, right? I just had a sandwich. So there are people who have 3-4 sandwiches and still they are lean. And then there are people who have just 2-3 bites and still they have the issues of bloating, issues of this, that, and so on. So every person is different, so that person's diet should be different, yoga should be different, exercise should be different, discipline should be different, they have different issues in different seasonal components and so on. So this is what is actually defined in this particular field. And these are all different issues or factors which defines the current status of that particular person. Right? So age is a factor, gender, time, upbringing, friends, family, season, habits, your family issues, your stress issues at home, at office, and so on. I just came almost, so when I started from home, it showed 30 minutes. I actually came here in 45 minutes, so there was 15 minutes delay due to traffic jam. So those 15 minutes has resulted in some kind of stress in my mind. I was worried whether I will come on time or not, and that stress will remain throughout the day till I do something about it. And everything is getting accumulated in some way to make prakrut, which is your healthy baseline position, to vikrut condition. So there is something called prakriti, more like your kundali or your genetic information and so on. And vikruti is what you are today. So epigenetic, what is your imbalance state today and so on. Right? So what is the imbalance? So that is what we again work. And this is what, after all, is the baseline. Every human being is the author of his or her own health or disease. So whatever you want to achieve, only you can do that. Not doctors, not this, not of course. If something happens, of course doctors are there, but you can get your balance state as soon as possible. So where AI, where computer vision can actually help. We have seen so many examples where the traditional way got converted into the new way, where intelligence happened. So now maps helps us. We don't have to ask questions over during our journey to people on every nukkad and all, but Google is actually giving us examples. Learning can happen on chess. On LinkedIn we are getting suggestions with respect to people and so on. So everywhere we see that different applications of computer science is actually helping betterment of humankind. This is the figure, okay, total figure of the system Ayurveda, okay, the conceptual foundation and logic. Okay. It's a very complex, so a particular person actually goes through so many parameters, okay, so many, if you Google Dr. Tillu, Ashok Vaidya, some names and system Ayurveda, you will actually get this particular photo. So there are so many gunas which are defining the human body. There are so many doshas, 3 gunas which are defining your mind. So it's all about body, mind, soul, different levels at different. We hear this throughout our life, right? There's Saptadhatu, Saptadoli. So it's actually covered in this complete figure. So if we can actually come up with a completely automated solution, that a person is front of me, okay, and suppose this is a clinic, okay, and the person is actually walking and coming here, the doctor is sitting here, and let's assume that there are cameras which are actually recording how that particular person is walking. So there is a gait analysis. I'm sure gait analysis in last 7 days you must have heard or studied that. So how a person is walking, fast, slow, how many times the hand is moving, how many times the legs are moving, and so on. enters whether that person sits first or waits for the doctor to instruct. Whether the patient talks first or the doctor asks, and then the sensors are capturing all this information, and through our smart programming we can actually make sense of all the emotions, all the diseases that particular person is going through. And of course, while coming in, there will be a kiosk which scans the entire body. The watch is actually already sent all the information to the doctor already. We have a couple of solutions. Those report cards are already at the doctor's desk with the reports ready and so on. So that is how you can envision how the near future is going to be. Very quickly, I am going to explain you 3 types of people. Okay, so whether we can create a solution based on automation, based on computer vision. To start with, create 3 categories of people. Okay, so suppose we are going for a movie. So and we can imagine this: our friends, families. There are 3 types of people everywhere. Okay. Suppose we are going for a movie. Okay, so there will be one category of people who are doing the guessing. We get the best line. What will Shah Rukh Khan do in this movie, and so on. Right. The second category of people is good at making plans. Which movie will go, which theater will go, how we will go, and so on. And the third category is more like munching on track. Right? So आप लोग decide करो, I will come.
Movie will take this scenario itself.
We can imagine here also that there are people who have made the plans and some have just joined the match. After the movie also, there are people still talking about screenplay. The other category is talking about अब क्या करेंगे, कहाँ dinner के लिए जाएंगे, and so on. So that's second. Third is still stretching, yawning. So again, if you see an accident, okay, or a snake, the first category runs away, screams, and so on. The second category actually solves the problem. There's an accident, they actually get down of their car, they go there, try to solve that particular problem, and so on. So that's another category. And third category, oh, there is a snake or there is an accident. Again, if there is a कुछ तूफानी करते, that kind of people. Let's do something. Second category again, organized game, organized prize, this, that. And third category will be, will be happy, nice party, a very close group of friends, families, and so on. So, and they have some names in it. Okay, typical. और ये word शायद हमने सुने होंगे. So now Tata tea comes with Vaat Pitt Cough. Teas. Toothpaste में आजकल नमक नहीं होता है. They have some Ayurvedic this thing. Okay, so the world, the FMCG products are moving towards Vaat Pitt Cough, and we are surrounded by Vaat Pitt Cough environment. We are some combination of Vaat Pitt Cough and so on. So sometimes we make the plans for the movie, but if some higher Pitta person is there, then we go to the third category. Okay, ask to decide that I will come, right? So it's not that our body or our mind is always with. Our environment, our atmosphere has a very high effect on us. So today, who am I is very important with respect to disease, with respect to environment. Now today I am here to learn something, for example. Then I go from Pitta to Vata person, and so on. So can we really do that? Okay, so that is very important. So we have to make sure that we open up our eyes, open up our ears, we sit here, and from our typical leadership properties of second category, we remove them, we keep them aside, and we open our ears to listen to whoever is talking in front of you, right? Very quickly, what we do in our company, next 3 slides, what we do. So what we have done is we have computerized the language of Nadi Pariksha, which is more like an art into a digital format. And it talks about again Vaat Pitt Cough. So a Nadi on a single artery can actually give complete information about what's going on inside the entire body. It's a typical Guru Shishya Parampara which has been there for last 5,000 years. There are more than 6 lakh doctors in India, and we are trying to go beyond them so that we can cater to 120, 130, 140 crore people, and of course eventually outside of India also. So what we have done is the manual method of Nadi Pariksha. So instead of 3 human sensors, we now have 3 pressure sensors, and they are basically collecting the information, and we give different types of report cards to the people. and it's helpful in the doctor-patient conversation. There are multiple report cards which we generate. So it's a first kind of diagnostic system in the field of Ayurveda. So till now the entire system has been more like a question-answer based system. So now there are also report cards, numbers, comparison, and so on. And of course, typical to Practo, Healthify Me, and so on. We also give scores, we also give advices with respect to diet, music, and so on. We are coming up with a completely new patient-centric app where we have digitized more than 4,000 recipes. So when you download it, you actually get the ingredients, recipe. जो main problem होता है females का, आज क्या बनाऊँ, कल क्या बनाऊँ, right? So we are trying to solve that problem for people. So far, at the moment, we have more than 800 centers across India and now also in 12 countries. We have catered more than 350,000 patients, 9 commercial MOUs in India as well as outside of India. And so the product is now patented. I also have one more patent due. So that's the meeting. Sorry, we had to rush today because on sudden basis at 2 o'clock I got one patent related meeting. Essentially what we are trying to do is this company, this product is now IEC, ISO, CDSCO certified. So whenever we solve this problem from computer science point of view or computer vision point of view, we have to make sure that that technology holds the complete merit in the world, in the sense that it has to be certified, it has to be, it should get all kind of approvals, whether, so from medical device point of view, these are the certifications. From if we are working in some other, we have to make sure that our technology or our findings finally reach out to people in the most sophisticated way with all kind of approvals and certification. It has to be patented, it has to be made sure that we own that particular. So today we are catering to more than 5,000, 6,000 people every day, and our vision is to cater to 50,000 people and ultimately 50 lakh people every day using our technologies in various formats. So we got, so I see the name ATAL, so we have received about a 1 CR grant from ATAL Innovation Mission to specifically work on diabetes. So for the first time, from Ayurveda point of view, we will work towards diabetes, completely holistic, completely personalized. So we should come out of the number system which the Western world is imposing on us and so on. So the number 5.6, the number 120, 180, we should come slightly above those numbers. If my lifestyle is good, I should be allowed to have some mangoes in those seasons. If my lifestyle is bad, then we should think otherwise, right? So that is how we have started. So now ethics clearance is done, the data collection is starting. We are also working with different governments' primary healthcare centers. So there are 8 lakh healthcare centers across India. Imagine Ashtavida Pariksha, all 8 images, videos, data, lots of data is coming from all those centers, and there is consultation. So whatever is happening at 50 rupees, 100 rupees for those people at those tier 3, tier 4, tier 2 cities, if we can cater to them in 10 rupees, can we give them solution with respect to diagnosis in 10 rupees? So that is precisely what we are. And we are also coin partner with TCS, so co-invention partner. So we are working on a couple of corporate wellness related products with them, how to improve the performance and so on. Again, completely based on, so you can imagine TCS working in Ayurveda, large corporates. We are working with a very large Germany-based company specifically for Ayurveda. Of course, US is working very hard. I think I'll skip this. I'm sure you must have heard or this for last 7 days, lots of time. I'll give few examples with respect to how imaging or computer vision can be used, which we have learned in last 7 days. We have been working on this for long. One of the projects also happened in PCCOE itself. So these days we keep taking selfies, right? So what we actually tried was more like a tongue fee based app. Okay? So every morning we'll take a tongue photo. We can also try in your families. So our tongue actually has different colors, coating, cracks. Crack is on this side, crack is on that side. So there is a huge literature in the ancient science available with respect to tongue analysis. If there is some crack in this side of the tongue, what does it mean? If it is malfunctioning on this side, then what is? So maybe a simple, so currently I am working with IIT Kanpur on this particular project, but there are MOUs with a couple of more institutes also. So basically this particular iPhone or all current Android phones, they are all face recognition based, right? So you can open up with this. So we are currently doing video based analysis, this analysis. So you actually take a couple of videos and it actually finds out different types of colors, textures, spots, edges and so on. So you can imagine different aspects which you learned over the 7 days with respect to video to images, segmentation, giving actual meanings to those patterns, noise removal, what to do with different images from different angles and so on. So you can imagine how this can be useful. Again, with respect to face also, we are doing multiple things with respect to, there is something called Anguli Parikshan. Okay, so as common people, because we have learnt over the years, when we see a face, we can actually imagine कि शायद ये this particular person might be a typical angry person or this will be a soothing person, right? So a face structure has some meanings. Okay, so there are ratios on our face which defines those typical emotions of that particular person. When you see a face, right? So some learning has been done in our brain. It has. No one teaches that, but when we see so many faces and when we interact with so many faces, that learning automatically happens. So we are trying to do in the similar fashion which faces defines what and so on. So this work started again with one particular project. So about 6 years ago, Facebook had one challenge called 10 years challenge. So you had to post, today's photo and your photo of 10, how you used to look 10 years ago. So those kind of images Facebook had. So we actually downloaded such 500 photos and we tried to find out which ratios actually did not change. Can those ratios be important? So again, purely computer vision problem statement to understand what can be done. Again, different types of image analysis, video analysis with respect to Anguli Praman. So there is something called Anguli Praman. Every person has, for example, forehead size, nose size, your lip size, lip width, height and so on. And how do I define? So in those days when there were no scales, they defined with respect to Swa Anguli, your own finger size, right? So how many fingers my lips are, how many fingers is my forehead and so on. So we are trying to find out different ratios beyond, of course we are also doing astro related work, there is that. So ultimately different types of our own sciences, how to combine them to create a solution. Again, there is a Akruti Parikshan, so a person is standing like this and they will do a few things. So how does it actually look and so on. So what are the different shapes, what do these shapes define and so on. Ultimately we are creating a platform. Ultimately the way Google has a platform, Facebook has a platform, we are creating something called Ashoka platform. So my whole work started with someone called Viraj Wadate. He's the one who treated my father basically. So that's why the name Ashoka. So AI and sensing based holistic oriental knowledge based architecture. So that's how we define the Ashoka platform. Imagine there is a Ashoka platform and 3 years down the line when you go to Swiggy to order some food and the Ashoka platform is now linked to Swiggy, it actually displays only those hotels and only those dishes which are applicable for you and your family. Imagine 3 years down the line your insurance premium also has the Ayurveda angle. So right now we do EEG, we do ECG, we do blood sample based. So you actually define how the person is and based on that the premium is defined. So imagine that Ayurveda, the integrative medicine is also involved to create that premium and so on. Ultimately whatever we are doing is to make sure that it becomes absolutely predictive. So there are 5-6 stages which are defined in modern health with respect to most healthy to most active disease. Similarly, Ayurveda also has multiple stages. So can we actually use all kind of technologies to do personalized and predictive kind of solution so that it actually helps? My team, small team, we are a very small 25 people startup. Parag is my friend from IIT Bombay. He takes care of the technology aspects, the hardware aspects and so on. I take care of the some PR, fundraise, some research, sales, marketing. And Tejaswini and Shruti are basically the domain expert. The interdisciplinary approach is basically when the domain experts are, you have a very strong team of domain experts. So Tejaswini is our Ayurveda expert and Shruti comes from the nutrition, very strong research background and so on. Just to end, again I'm re-stressing yoga, Ayurveda, timing for technology is now, so that we make sure that we provide the best solution for the to people to be most balanced. I've noted my email ID and phone number there. So if you have, I mean, of course we'll discuss here right now. But if you have any other questions or anything you want to, we want to talk later, I will be most happy. The same number is also on WhatsApp. So if I don't pick up, please. Thank you again for inviting me here. And I'm sure you must have learned a lot about computer vision, how to apply that into while you are doing your projects in your institutes. Make sure that you actually collaborate with your fellow department people to solve a particular interdisciplinary problem. Make sure that you create a 2-year plan, so that 3-year plan, 5-year plan, so that you can split that into multiple years, and so that every year you assign students to do that much, that portion of work. Because in 1 year or one section of students cannot complete the entire project. So you have to make sure that you are actually creating a nice path for your students, so that they also know where they come into the picture, where they leave, so that the next, in typical corporate life, the KT happens, the knowledge transfer happens between this particular year and next particular year, and so that they can pick up, go faster, and so that the last batch actually delivers the final output, final project in hand, which is actually in a product format. Okay, so we Indians are good at research, but not in products. We don't deliver products. We don't deliver the final output to people, right? So it's now high time that we start generating money, generating research, generating patents, generating products. Current era is very good, ecosystem is very good, lots of money is there in research grants, and so I highly recommend apply for as many grants as possible, get the best students, work with each other, work with industries like us, so that we give you the exact problem definition which needs to be solved, so that we get free students working. Otherwise, computers, full setup, 3D printers did that. Usually all colleges usually have these facilities these days. So let's create a very good ecosystem eventually, so that we make. So I actually see apna time aane wala hai. By 2030 we will be the 3rd largest economy in the world, and that will happen only if we have technologies, if we have patents and so on. So let's work for it. So thank you Abhi. If you have any questions, anything you want to discuss, I will be happy to answer.
So, only on the basis of this Nadi Parikshan, like Ayurveda, can we identify, detect the diseases like cancers and all? Because nowadays, blood cancer is common in ladies because of the hormonal changes, right? And at the first stage, we cannot predict it. So, only at the final stage, it is going to have that kind of prediction. And we have to go through number of tests, right? And those tests are again heart burning tests. So, can we rely on Ayurveda for this, or we have to club with allopathy as well, those tests?
So only Ayurveda will never have the solution. It has to be, an integrative solution. Does Ayurveda have solution? Yes. Does Ayurveda have a diagnostic system? Yes. Can Nadi Pariksha do it? Yes. Can the product in the current format do it? No. We don't know. The complete clinical validations need to be done. So far in last 20 years, I started with my PhD postdoc last 7 years. We have been playing in the field of wellness. okay, more in the stamina, flexibility, stress, anxiety and so on. So, which in a way does not need any clinical validations to go into the market, to make money as a company, right? But now we are entering into the health with diabetes this year because we have received the grant. We'll be working in 20 states, 10,000 people, solid, cleared, ethics cleared body with consent and so on, so that we actually come up with a diabetes monitor. So, 2 years ago, if you had asked me the same question, can diabetes monitor possible? So today I would say yes, diabetes monitor. So it has to be similarly to be done with respect to anxiety, cancer, hormonal. So next we are taking hormonal because these are the important issues. For cancer, there are so many solutions already there. But for these, we feel that Ayurveda has better diagnostic solution, better finally solving solution also. Right? So yes, the answer is it is possible, but it has to be done in the right way with the clinical validations and so on. So today it cannot be done, but yes, in near future we see that happening.
So also sir, up and down positions.
Yes.
The woman characteristic or fertile or not fertile.
Absolutely.
So the doctor, there is some recognized such things.
Yes.
So can we use some computer vision or SCA
Yes.
things like that?
Absolutely.
So we
Absolutely.
can go for that.
Absolutely. So we have to make sure that we come up with a protocol.
Yeah.
How much tongue to be done in this way, that way, and so
Up,
if
up position.
up and so there are various factors. So when you, I mean, there are distant people, but from close I can actually show you. When you actually take your tongue completely up, so whatever, yeah. So whatever you actually record as a video. There are so many factors which define so many things. One of them being what she just said. So yes, so that's why I mentioned about face, videos, tongue, all those things. Yes, computer vision based application, product, technology possible. A lot of institutes are working on it. They have still not able to crack. So there is a scope. So there is a huge scope, and we should do it.
So the data is the way thing.
Absolutely.
Exactly.
So when we started with respect to diabetes, we collaborated with one particular hospital and one particular yoga institute, and we worked only on 500 data. We published in the best possible journal. It took time, but best journal, we published our preliminary results saying that classification is possible. That's all. And the paper titled preliminary observations, right? But based on that, when we submitted that to the grant people, they accepted it wholeheartedly. For the first time, Niti Aayog has given such a huge grant for Ayurveda. It's a very bold move from our government also. So that 500 data resulted now into 10,000 data collection, which will actually do. So in the similar way, we start with 100 data points, start with 500 data points. We actually show that there is some correlation, there is some distinction, there is some classification. Then we go to the next, we apply for grants, we get more data, we involve domain experts again, who defines what is tongue, what is up, what is down, how much up is up, and so on. It has to be defined, it has to be documented, it has to get the ethics clearance, why this has to be done, how many times we'll do this, and so on. So once that is done, then the problem can be solved.
Sir, can we do
Mala Aniruddha, my name is Aniruddha. Please, maybe you guys are more. Yes.
Can we diagnose early diagnosis of blood clotting using Nadi
Yes,
Tarangini?
absolutely.
Because I searched previously and I read about the Tarangini, but I found very few papers on that and even very few information on your website also. So can we do that?
Absolutely. I mean, as I said, we have been so at the behind we are working on multiple things, but on website we write only that thing which is commercially possible. I run a commercial activity. When you are at a institute, you can be slightly bolder, but at our stage we cannot take any risk. No, we don't want any paperwork basically. Right? So yes, can be done. All cardiovasculars are possible through Nadi, but again same. We have to prove it clinically. Again data collection, again ethics clearance, again domain experts. Domain experts define this is clotting, that is not. At the same time our Nadi collection is done and we find patterns and we solve this with typical machine learning or deep learning problem and so on.
Because we, if externally we try to identify the clots, till we don't get any symptoms, we are not able to identify that
Yes.
symptoms.
So let me share a very simple one of the.
Because after COVID, that factor is increased.
Yeah.
Blood clotting and heart attacks.
One of my presentation. So this is something called lump model. Okay. So what do we see is there is a heart which can be imagined as a battery, a typical voltage current battery. So there is and every organ system can be termed as some combination of a resistor, capacitor, inductor, and so on. Okay. So there are so many organ systems, individual organs, small systems, bigger systems, and so on. And everything, something is passing, something is increasing, something is decreasing, something is holding. So you can imagine that in terms of a resistor, capacitor, right? And everything. So we know the how the typical voltage current system works. Everything is in parallel or series. Right? Now let's assume that the clotting or some issue is in this part of my body. Let's assume that resistance has increased. Right? So if the resistance is increased, but whatever is in series of that requires the regular blood. So now the heart defines to reach out to it, either it pumps more or more number of times, right? So that it can send the current to that particular affected area. But because everything is connected, now this particular position also receives in the similar format. It also receives the information that pulse rate or amplitude is increased and so on. So that is how the whole thing is connected. Now we have to establish clotting in some portion, in some whether it's in heart, whether it's somewhere else. How is the effect? How much is the effect of that clotting at this particular portion at the rest area? So one of the solutions is so yes, it is possible. It has to be established. Yes. So basically, again, the project has to be defined, and usually this runs 2 years, 5 years, 10 years project. Usually this is not a small world. Many times, students come to me in our, we want MTech project, we want to create a system similar to your, and we want to detect diabetes from it. Usually students think like that, oh, 4 mahine mein ye kar denge. But what they actually get is a very preliminary solution. So if the professor, if the teacher, if the guide actually creates a plan, ये करना है, उसको split करके we can do this. I think I'll stop here. I'll reshare my number and this. If there are anything else, I'll be happy. I'll be happy to. Yeah. So I'll be happy to discuss further. Thank you very much.
Before Shivani talks, I just want to share one experience. When you do research, we all do research. I look up Aniruddha as my hero. Because when you go to films, see what you cannot do when a hero does, you feel inspired. When a villain hits hero, you feel, oh, my hero is. See, whenever he gets fun, I feel very happy. Whenever he is down without funds, I feel very bad. Because my research, when I started, because when he says about his father, I cry. Because I also started my research because of my father. I lost my father because he got a ischemic heart disease. Okay, suddenly one day morning he was not there. But I did not go in detail like he did. Like he said about research and product. I tried PhD with 6.5 years, data collection, connecting with doctors, lot of things I tried. But finally it became a research. So 10 papers, 12 papers, it ended with a paper only. See, the Madras Medical College, doctors were very happy. But is it a product? No, it's not a product. And I left that dream. After that, some students worked. We could not, diabetes, we had some discussion. But to go to a product, no. So I look upon him as a hero. What I cannot do, if he is successful, I think we all have to do this. Somewhere we have to break this, and we all, if 30 people are inspired with his talk, that is the success of this FDP, I feel. Okay, so success of our FDP is stop research and get into products for you and for me also. Thank you very much. It was an inspiration.
Thank you, Dr. Joshi. Thank you for ending this FDP with such an interesting and relatable session. Now, I would like to invite some of the participants to share their feedback.
One or two only?
Yeah, I would like to invite Ashwini.
Crunch of time.
Yeah, Ashwini.
I'll make it.
The very natural transition of all those people is going to be Ayurveda. But Western world, even today, especially in India, is not going to accept Ayurveda as one of the interdisciplinary research field unless we provide them.
Just now, today morning only, I have shared with all of you the updated reflector journal format. So you are supposed to, prepare that document. Then one document for article summary. Actually, that you are supposed to do in that Google form only. Day-wise, session-wise, we have handled. So it will just go to the first page. When you move to the section 2, you are supposed to see that. Because right now you will not, attempt all the questions on section 1. You are not moving. You will not move to section 2. So in section 2, section 3, section 4, section 5, accordingly we had divided the according to the assessment criteria to the ATAL FDP. So you are requested to complete it by today, end of the day. So 5 p.m. we are keeping as a target.
So we have to.
Because anyhow you cannot submit the MCQs right now.
Good afternoon everyone. I am Ashwini. I am a research scholar at CLP Technological University and a faculty at PCCOE. At the onset, I would like to thank for giving me the opportunity to express my gratitude. So I would begin with the organization of this FDP, starting from the AICTE for giving us the grants, PCCOE, our Honorable Director Sir, the team, the organization committee team led by Dr. Rajeshwari ma'am, Dr. Deepa ma'am, and all the organization committee members. Big round of applause. That goes in the background to organize a 6-day program. If I have to invite for one meal to anybody at my place, it takes so much planning. So they have done it for 6 days. Starting from breakfast, organizing, arranging commute, doing the communication with all the experts, arranging for their stay, arranging for their transportation. I mean, so much of work must have gone in the background. So really, big thank you to them. IITs for us from academics and researchers and society in general can be equated to the place of worship. And I feel they have brought the gods to us for these last 6 days. And I always inviting the professors, the researchers from IITs, NITs, IIITs and the government institutions. So big thank you for that. I feel though after 6 days of the FDP, we might have just touched the tip of the iceberg. There is a lot to be learned, which I think is individuals' effort now. Will go into taking this ahead in your research or developing a product as ma'am said. A big thank you to students who have captured all our videos and all our photographs, and I hope they don't do any study on who was sleeping during the session. So ignore do the segmentations and ignore those things, okay? Take them out from
You have become a teacher
slide.
now.
Sorry. So take those things out. It was also an opportunity to meet the faculty from the different organizations, institutions here, from in and around Pune, and to understand what work they are doing. As ma'am said, to keep it simple, I have one more page, so I'm skipping it. Thank you so much.
Thank you.
I would now like to invite Mr. Ravindra Kakre sir for his feedback on the sessions.
Sir was the sincerest, the most sincere student of this FDP. So let us all acknowledge him.
Namaste to all my friends who have participated in this FDP. Friends, I am from rural area. My colleague also is here with me. That is Navara Rural Education Society, which is very near Kushedi. Now, our Education Society has been started in 1964. Now, in 1981, the first polytechnic government, I mean say, private polytechnic started, and in 1983, first engineering college started in Prague. Now, late Augmentation, Padmasri Ravi Patil started in 1964, our Education Society with 20 girls only. From rural areas, 20 girls they have started Aurora Kanya Vidya Mandir. Now, Augmentation Dr. Balasaheb Patil has extended these activities. Nowadays, 45,000 students are studying in our Aurora Society, and 114 different institutes are there. Now, we have engineering colleges, so we have 2, 3, 4 engineering colleges. We have junior colleges, we have 15, 16 junior colleges. 50 means our area is 40 kilometers in a circle. We have in 5 kilometer school, and we found junior college and we found senior colleges. So from that background I came here. Now we have seen that our Rural Society's development was horizontally. Now we have seen in Pune it's vertically development. Now our chairman, you might be known, our Revenue Minister, Honorable Viraj Wadate, helping us for doing towards good education and quality education. Now this FDP has been an incredible journey for growth, learning and collaborations. On behalf of all participants, I extended my best, deepest thanks to PCCOE, Honorable HOD Madam Dr. Rajasri and his organizing team for envisioning and executing such an empowering initiative. The success of this program wouldn't have been possible without the dedication and tireless efforts of our experts, IITians. The persistent industrial visit was very really wonderful. We remember it very much. Once again, thank you everyone involved in these arrangements. Your dedications played a crucial role in making this faculty development program a comprehensive success. Thank you very much.
Now I would like to invite FDP co-coordinator Dr. Deepa Abel for water science.
Just give me 2-3 minutes. Dear all, good afternoon. It's a moment of pride and joy to stand before you all today to give this thanking note as co-coordinator of the 6 days ATAL FDP on computer vision for multidisciplinary research. This ATAL FDP conduction came into realization with the trailing footsteps of attending a computer vision conference with HOD Madam, she attended as a part of Anubhan scheme for professors, and me attending with CV domain at IIT Jodhpur. We were delighted together to witness the event hosted by them and wished that we also could have the IIT professors as part of some occasion in our campus. This opportunity came through the sanctioning of this ATAL FDP proposal that we put up together. I take a moment to thank the PCET management and our Honorable Director, Dr. Govind N. Kulkarni sir, for being such a visionary and fostering ideas amongst us and guiding us through, so that we pursue them to have such fulfilling experiences that we are having today. My sincere gratitude to Head of the Department and ATAL FDP Coordinator, Dr. K. Rajeshwari Madam, for believing in me and to give me this opportunity of essaying this role as FDP co-coordinator. This FDP's core highlight was the topic, Computer Vision for Multidisciplinary Research, and the eminent speakers from IIT Guwahati, IIT Palakkad, IIT Jodhpur, Institutes of Repute, the Tyagaraja College of Engineering, VIT Chennai, and Anna University, and also the industry expert sessions that we had. Sincere gratitude to all the resource persons who gave their kind consent and came all the way to deliver the sessions here. We started off with an overview of CV techniques on day 1, to feature extraction methods overview and in-depth algorithms on SIT, SURF, and HOG on day 2, segmentation techniques and applications on day 3. Day 4 we started with CNNs, object detection models and applications. Day 5 with industrial visit to persistent, taking us through all recent applications on CV, extended reality and biomedical applications. And on day 6 today with GANs, encoders and transfer learning. And towards the end, that impactful session by Dr. Aniruddha Joshi sir. We also had article discussions and hands-on sessions with enthusiastic participation. It has been a week of technical depth altogether. So our sincere and heartfelt gratitude to the organizing team of Computer Engineering Department. I want to take a moment and to share the names here.
Can you please come here?
They have been the core of this FDP.
Wouldn't have been possible without you. Please come here. I want you.
Dr. Sarika Devkate, Mrs. Deepali Nayak, Ms. Shivani Pandey, Mrs. Meeta Khairnar, Mrs. Mehzabeen Pathan, Mr. Pankaj Devre, Mr. Vinayak Malavade, Mrs. Manjari Ranjanikar, Mr. Ganesh Kadam, Mrs. Madhuri Suryavanshi, Mr. Anil Pawar.
Okay, let's all give a big hand for them. Short time actually, they could manage everything, morning to late nights.
We will have one.
We will have together. I just wanted them to know you. Thank you. They're all new team actually, new team at PCCOE mostly. All are like 4 or 5 months back except Swati Chandrakar madam and Smita madam. Thank you.
Thank you. Equally supported by the technical staff, Chaudhary sir, Snehal madam and Preeti Jadhav madam. Special thanks to department clerk Jadhav sir, the support staff, Sagar, Gopale, Ajay, and the whole department for all the direct and indirect support always. Our gratitude to the persistent team for their kind consent to host us for the industrial visit as part of this FDP, and also to the student team, yes, for the relentless efforts, and post FDP also some work. Thank you.
So before what thanks is there?
Yes, advance thanks. Yes. And last but not the least, I thank all the participants for all the good interactive sessions that could be possible because of your enthusiastic participations throughout. We enjoyed it. And thank you so much, and looking forward to all such good collaborations in the future too. All best wishes, and wishing you all the brightest Diwali in advance. Thank you.
Now, in 1981, the polytechnic, first polytechnic I will say, private polytechnic started in 1983. First